Okay, let's start this way. Let's start by, let's express z equals 4I in polar coordinates. Well, in polar form. So what I have here is z equals 0 plus 4I. So if we think about where that is on the complex plane, that's right here. Well, that's actually pretty easy, right? Because this is pi over 2 for my angle, and my radius is 4. So 4I simply equals, and we're going to go r e to the pi over 2I. Because remember, we are going from z equals a plus bi to, and we can go both ways, z equals r e to the I theta. Okay? Let's do another example. Let's find the polar form of the complex number z equals -8. You might think that doesn't look like a complex number, but it is, because that is -8 plus 0I. So if we think about graphing that on the complex plane, we're over here. And my angle is simply pi, and my radius is 8. So this is eight e to the pi I. Okay. So now let's get to the why. Well, let's go the other way first. Let's go the other way. Let's write 3e to the pi over 6I in a plus bi form. Okay, so I've got z equals 3e to the pi over 6I. This is z equals r e to the I theta form, which means r equals 3, theta equals pi over 6. We remember that a equals r cosine theta, b equals r sine theta. So in this case, a equals 3 times the cosine pi over 6, b equals 3 times the sine pi over 6. Cosine of pi over 6 is root 3 over 2. So that's 3 square root 3 over 2. Sine of pi over 6 is 1/2, so that's 3/2. So that means that my complex number, 3e to the pi over 6I, can be rewritten as 3 square root 3 over 2 plus 3/2 I. Okay? So why? Well, let's go back to that example I did a few minutes ago. And let's do that in the next video.